Hello everyone! Welcome back to my YouTube channel. Again, my name is Rugame Casabana from ECE31 with my group mates.
I'm Jose Alvaro II from ECE31.
Hi, I'm Jimweleyan Tulbian from ECE32.
And for today's digital electronic vlogs, we will be focusing on our final project, which comprises of 4 conditions about our water tank. That will be explained later on as we go on the experiment. So just stay chill, listen, and learn, and I hope you'll have fun with our experiment for today. Now, before we start the experiment, let me provide you a brief introduction on what to expect on the paper as we go on the experiment. For our objectives, we aim to fully understand the principle behind switching theory and logic design. Now, leading us to our second objective, we need to apply the principles learned about our logic gates and our logic principles to be able to complete the final project. For our third objective, which is to present it clearly and fully on a video presentation. So I hope you're going to learn. Now, to fully understand what is switching theory and its relation to Boolean algebra and our logic principles, let's understand the switching theory. Switching theory allows us to understand the operation and relationship between Boolean algebra and logic circuits, which may include logic gates. Simply speaking, switching theory is a mathematical condition which allows us to use logic gates as well as logic principles to come up with a digital system that can be used to improve our modern technology for today. So now that you have a brief idea and introduction about switching theory, I hope you're ready for the experiment. Let's start!
We can see that a chemical plant needs an alarm system to warn critical conditions. These conditions included temperature, pressure, fluid level, and weight. And these parameters has 2 states, which is the high and the low. Using our knowledge in switching theory and logic design, we will construct a circuit that will sound the buzzer for a period of 30 seconds. In the following conditions arise. For the first condition, the buzzer will alarm with high fluid level, high temperature, and high pressure. For the next parameter, low fluid level but with high temperature and high weight. For the next parameter, low fluid level with low temperature and high pressure. And finally, low fluid level with low weight and high temperature. One of these conditions satisfy, it should sound the buzzer for a period of 30 seconds. In able to solve this, the given hint, we should use K-map to simplify these given conditions that is mentioned above. And
before we start the experiment, I hope you can still remember the basic foundation and basic principles of logic gates as well as Boolean algebra in order to fully understand the processes and the mathematical computations that we will be using to treat our data to effectively perform the experiment. So I hope you did a little review, and as we go on the paper, we will be explaining the logic behind each process. So just keep on watching. To provide you an overview of our output paper, we will be providing a truth table, a Boolean function, a schematic diagram, and the actual circuit using our breadboard to verify the correctness of our solutions to the problem. Of course, to verify if our connection and our simulation using the breadboard is correct, we will be verifying it using our multi-sim software that will prove the legitimacy of our breadboard simulation. Now, for our problem solutions, we will be considering 4 parameters for the water tank conditions. First one is the fluid level, or the letter L. Second one is the weight, or the letter W. Third one is the temperature, or the T. And the fourth one will be pressure. For our Boolean expressions for the 4 conditions, we will be considering LTP for the first condition, wherein L is at logic 1, T is at logic 1, and P is at logic 1, meaning all of the temperature and the pressure as well as the fluid level is high. For the second condition, we will be considering the Boolean function, which is L not TW, wherein the fluid level is low, the temperature is high, and the weight is high. For the third condition, we will be considering L naught, T naught, and W, meaning the fluid level and the temperature is low while the pressure is high. And for our fourth condition, we will be considering the Boolean function L naught, W naught, and T, wherein the fluid level is low, the weight is low, while the temperature is high. So that's the 4 conditions with the 4 Boolean function that we need to satisfy for the alarm of the water tank to work properly. Using those 4 Boolean functions that satisfy our water tank conditions, we will be deriving 8 Boolean functions, which are a combination of the 4 parameters. And after that, you have to take note of those 8 Boolean functions. Now, for our K-map, we will be deriving 16 possible combinations of the 4 parameters that will yield to different outputs. And we will be numbering them to trace the 8 functions that we derive from the 4 water tank conditions that were satisfied. Now, tracing the 8 Boolean functions from the 16 possible combinational outputs from our K-map table, we came up with these numbers satisfying the 8 Boolean functions. It is number 2, number 3, number 4, number 5, 6, 7, 14, and 15 that we will use to create our K-map. Now, you just have to retrace these numbers on our K-map, and then after that, regrouping all of the numbers to properly come up with the final Boolean function that will satisfy the whole water tank condition for this problem solution.
The materials that we will be using for the final output are 7408 AND gate, 7404 NOT gate, 7427 triple input NOR gate, 7411 triple input AND gate, buzzer, LEDs, connecting wires, 360 ohm resistor, and a power supply. The materials listed at the left side of your screen are optional if ever a prototype is created. But because of the limited resources brought about by the difficulty of traveling due to the pandemic, a circuit simulation using multi-sim and breadboard is considered by the experimenters. The materials are water tank or water bottle, temperature sensor, pressure gauge, weighing scale, and fluid level gauge. Integrated circuits, pin configuration. 7404 NOT or inverter gate IC. As we can see in the picture, the input and output pins of an inverter gate. The pins 1, 3, 5, 9, 11, and 13 are for the input, while pins 2, 4, 6, 8, 10, and 12 are for output. Pin 7 is for ground, and pin 14 is for the source. Next is the 7408 AND gate. The following pin configurations, such as the input, output, ground, and source of the AND gate, is illustrated in the picture. Lastly are the 7411 triple input AND gate and 7427 triple input NOR gate. Both of these ICs have the same pin configurations, as we can see in these pictures that the input and output pins of them are identical.
This is the circuit for our experiment. As we can see, there are three inputs, which are the temperature, pressure, and fluid level. According to the principles in physics, pressure is directly proportional to the weight. Therefore, we decided that there are only three inputs for this experiment. The temperature is connected to the two AND gates, while the fluid level is connected to the NOT gate, and the output of the NOT gate is connected to the one of the AND gates, and it is also connected to the one input of the triple AND gate. The pressure is connected to the one of the AND gates, which is here, and it is also connected to the one of the input in the triple AND gate. The remaining input in the triple AND gate is connected to the 5 volts, which makes that input always on. And in every output of these AND gates, including the triple and the output of the triple AND gate, is connected to the inputs of the triple NOR gate, which is the 7427 IC, and the output of the triple NOR gate is also connected to the NOT gate, and it is connected to our buzzer and to the probe. The probe is indicating in which will determine if the circuit is working for our given parameters.
Now, to construct our circuit, we will be needing the following materials. First is our breadboard that will serve as the base or the mounting surface of our electronic components. Next one will be our ICs, which are shown on our schematic diagram shown in the screen. And for our output, since we do not have a buzzer or something that creates a sound for our alarm, we will just be considering a red LED, or let's say any color LED that you wish to use that will serve as your alarm system. Next one will be our 360 ohm resistor. And of course, do not forget our connecting wires, and of course our voltage supply that we will be connecting later on for our output and for our truth table. Now, let's start constructing the circuit. don't forget our 360 ohm resistor para hindi mabigla yung ating LED kapag iilaw na siya. And for our output, we will be putting our LED in series with the resistor. Now, do not forget the most important part of our circuit, which is the connection of our integrated circuits to our VCC supply. Okay, so let's connect all of the integrated circuits on the voltage supply. So it's on the 14th pin, the VCC connection of our ICs. And of course, do not forget the grounding of our components. Let's ground first our LED here. And now let's all ground our integrated circuits on their 7th pin. Okay. And this one, let's ground our second IC. And of course, do not forget to ground our last IC here. So for our inputs, we have our white wire here, we have our yellow wire here, and we have also our blue wire here for our 3 inputs to satisfy the conditions for our problem. Now, for our voltage connection, let's connect our power module to our power supply. Now, proceeding with our truth table for our expected outputs, let's consider the white wire as our input for the fluid level. Okay, let's consider the yellow wire for our input for the temperature, and the blue wire, which will be our input for both pressure and for weight as well, since pressure and weight is directly proportional to each other. Now, if we satisfy the first condition, which is we have a high fluid level, which is the white wire at logic 1, we have our high temperature, the yellow wire, which is on the logic 1 as well, and the high pressure, which is the blue wire at logic 1 as well. Okay, let's see the output. Okay, so let's connect it to the VCC and this one. As you can see, umilaw yung ating LED, meaning if the tank conditions is we have our high fluid level, we have our high temperature, and we have our high pressure, meaning the tank conditions is LTP, or all of the conditions are at logic 1, our output will be logic 1 as well. Or in the problem, if it's a buzzer, it will alarm or it will sound, and if it's an LED, it will turn on. Okay, so that's our output for the first condition. Now, if our conditions is that there is a low fluid level, okay, so it means that our wire, which is the white wire, will be at logic 0, okay, and if we have our high temperature, okay, meaning our yellow wire is at logic 1, and if we have high weight, meaning the blue wire is at logic 1 as well. Okay, so as you can see, our output will be logic 1 as well, meaning the alarm will sound, and in this case the LED is turned on. So overall, if our tank conditions is that we have our low fluid level, we have our high temperature, and we have our high weight attributed to pressure, the alarm system will turn on, or the LED will be at logic 1. Now, for our third conditions, if the tank conditions is that we have our low fluid level, meaning this white input here will be at logic 0, And if we have our low temperature, meaning the yellow wire here is at logic 0 as well. And lastly, if we have high pressure, or the blue wire here is at logic 1 here in the other end, as you can see, our output will be at logic 1 as well, meaning our alarm system will turn on and the LED is at logic 1. So overall, if the third condition is satisfied, wherein the fluid level of the tank is low and the temperature is low as well, while the pressure is high related to our weight, then the logic output will be at 1. Lastly, for our fourth condition, if the tank conditions is that we have our fluid level, which is at logic 0, or meaning we have our low fluid level, okay, so let's put it in the ground. And if we have our low weight as well, so this blue wire here, let's put it on the ground, okay, and we have our high temperature, or this yellow line here is at logic, okay, is at logic 1 connected here on the other end. Our output will be at logic 1 as well, meaning the alarm will turn on. That's why the LED turn on. Overall, if our fourth condition is satisfied, wherein the fluid level is low, the temperature is low, and the temperature is high, our output will be at logic 1, meaning the alarm will turn on. So that's our truth table for the tank conditions.
As we see on this side, these are the conditions that we should satisfy. And this is the circuit that we're going to test if the following conditions. In the first condition, there is a high fluid level, high temperature, and high pressure. So if we run the simulation, this would trigger the buzzer and the probe. On the next condition, there is low fluid level, high temperature, and high weight. In according to the principles of physics, pressure is directly proportional to the weight. So that is why pressure and weight are considered as one on this input. So if we play the simulation again, this will trigger the probe and the buzzer again. So for our next condition, there is a low fluid level, low temperature, and high pressure. So if we run the simulation again, this will trigger again the probe and the buzzer. And finally, for our last condition, low fluid level, low weight or pressure, and high temperature. As we run the simulation again, this will trigger our buzzer and the probe again. So this means that our circuit is perfectly fine or working properly. With the given condition on the problem that is stated, these conditions should trigger our buzzer, and as we see, these conditions triggered our buzzer with this circuit.
As our conclusions, the AND gate is a digital logic gate that implements logical conjunction. A high output, or at logic 1, results only if all the inputs to the AND gate are high, or logic 1. If a condition requires 2 or more inputs, a designer can use a 3-input IC or electronics component such as a 3-input AND and NOR gate in the experiment. Moreover, the 7411 IC contains 3 independent gates, each of which performs the logic AND function to treat the inputs. Lastly, the NOT gate or inverter fits the experiment because it performs logical negation on its input. In other words, if the input is true, then the output will be false, which is applied in our experiment for this episode.
Now, for our recommendations, it is important that you use the appropriate electronic components that will serve their specific purpose in the circuit so that the water tank conditions would be satisfied and the alarm will work properly. You also have to take note that if 2 or more inputs are involved, you can use a 3-port input AND gate or a 3-port input electronic component. Also, if you have a buzzer, it is better to use than an LED so that the alarm will work effectively and will sound when the alarm functions. And lastly, you have to ensure that the connection is right and you have the proper grounding for the experiment circuit. So that's all. So again, my name is Rica May Casaplena from ECE31 of De La Salle University Das Marinas, saying that I hope you learn from our experiments and I hope you'll never get tired of watching my vlogs and my videos to learn more about digital electronics. I hope you're gonna study well and enjoy dealing with your diagrams and with your circuits. I hope you'll keep safe and see you on my next vlogs.